Problem 25, page 189. Make sure you've read the problem before you go any further. I've got a sketch of it here. We've basically got two tennis balls with different masses traveling at different speeds that are going to collide with one another and then be moving at two new speeds, v1 prime and v2 prime, after the collision. And we're told that we're just to assume that it's an elastic collision between these two balls. So, if it's an elastic collision, we want to apply the principle of conservation of momentum. Which tells us that m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. And because it's an elastic collision, if you go back and look at review the idea of the coefficient of restitution, it's telling us that the relative velocities of the two tennis balls are the same before and after the collision, but in opposite directions. So it's telling us that v2 minus v1 is equal to minus v2 prime minus v1 prime. And we want to combine these two equations in order to find the two unknowns, v1 prime and v2 prime. And so I'm going to do that on the next page. So here are those two equations that I just derived by considering conservation of momentum and conservation of kinetic energy, or that it's an elastic collision. If I just number these, equation 1, equation 2, if I rearrange equation 1, I'm going to find that v2 minus starting again. From these two equations, everything on the left I actually know and I can plug in. m1 v1 is from my previous equation 0.06 times 2.5 plus, and m2 v2 is 0.09 times 1.15. So I can evaluate that as 0.2535 kilograms meters per second, and I can also evaluate the difference in those two velocities. v2 minus v1 is 1.15 minus 2.5. And that's equal to minus 1.35 meters per second. So these two equations up here reduce a little bit to m1 v1 prime plus m2 v2 prime is going to be equal to 0.2535, and v2 prime minus v1 prime from here is minus this difference, so that's equal to plus 1.35 meters per second. Get the units there as well. I can then rearrange this second equation and substitute for v1 prime in terms of v2 prime. I get that m1 times 1.35 plus v1 prime is v2 minus 1.35 plus m2 v2 prime equals 0.2535. My only unknown now is v2 prime, so if I solve for that, I end up getting that v2 prime is equal to 0.2535 plus 1.35 times m1, all divided by m1 plus m2. Plugging in the values for m1 and m2 will give me a value of v2 prime. And that's 2.23 meters per second. I then just have to substitute that value into there to get my value for v1, which comes out to be minus 0.88 meters per second. Sorry, plus 0.88 meters per second. And so they're both still moving in the same direction. The original tennis ball slows down a little bit, and the second one that it hit speeds up a little bit, going back to here. This one is now moving still in the same direction, but much more slowly, 0.88, and this one has gained a lot of speed and is moving faster in the forward direction.